Namaskar. I welcome you all in this class of mathematics. So, friends, in the last class we were discussing sequence and series. We have already discussed arithmetic progression and geometric progression. Now, we will today discuss the concept of summation. This is important concept because it is used in many of the problems, scientific as well as engineering problems. So, at many places you will see that you have to find the sum of a series or sequence, and how to do it in research and in many of your courses you will find such problems. So, suppose this is a sequence that is A1, A2, A3, AN. If we write it as a summation, A1 plus A2 plus A3 N, then we call it series. Okay. So, the common notation is that we represent it by sigma. Sigma I is equal to 1 to n, say xi, then we this this is the simple summation x1 plus x2 plus x3 and so on till xn. So, for all values of n. So, this is a series we call it, and we denote it by this notation sigma. Here we can change even the axis. This I is 1 to n. We can also write it I is equal to some value, say 2 to n x I minus 2. So, this will be the same thing. It will start from 0, x 0 plus x 1. If you want to start from x 1, then it will be I minus 1. I minus 1. So, then it will start from x 1. Okay. So, the origin can be changed. Similarly, some value k to n x. If you want to start from 0, then it will be x 0 x I minus k. We will represent it like this. Now, there are some basic rules of summation. Let us discuss those rules. Very simple one, you know, and you will find it that it is intuitively correct. You can use it also, but in mathematics nothing is exact unless it is defined properly. So, sigma I is equal to 1 to n k multiplied by I sorry. Only k where k is a constant. So, this will be equal to k multiplied by n. You know very well, this will be equal to I is equal to 1 to n. So, n times k will be added. So, it will be equal to k to 1, but this is the basic rule of summation. Now, the second rule is summation I 1 to 1, again k is constant and xi is x1, x2, x3 variable. So, this will be equal to k summation I is equal to 1 to n xi. It means that k can be taken outside and within bracket x1 plus x2 till xn. So, since k is a constant, I think there should not be any problem. You can very well understand that, right, kx1 plus kx2, we have taken common k outside the bracket. So, this series will become sigma I is equal to 1 to n xi. Now, the third rule is sigma I is equal to 1 to n xi plus yi. Suppose two series are there. So, this will be equal to sum of different series. Sigma I is equal to 1 to n xi plus sigma I is equal to 1 to n yi. Again, this also is quite obvious that if you write x1 plus y1 plus x2 plus y2 plus x3 plus y3, this will be x1 plus y1 plus x2 plus y2 xn plus yn. So, here you can accumulate x1 plus x2 at one place and y1 plus y2 at other place. So, this will become xi yi. So, quite simple rules are there, you can very well understand, but nevertheless we have to define it. Now, there are some important series whose sum, the formula for their sum you should remember, because it is used at many places. So, first one, sum of first n natural numbers. So, this will be 1 plus 2 plus 3 to n. This is simple because in the arithmetic progression we have found out the sum of the series of say S is equal to x1 plus x2 plus x3 xn, where xn is equal to a plus n minus 1 into d, where a is the first term, that is x1 is equal to a and common difference is d. So, this we have derived, we have already derived in previous class that xn is a plus n minus 1 d. So, this is a series in arithmetic progression. So, here x1 is equal to 1 and common difference is also equal to 1. So, the sum will be, so this is the xn. So, what the sum is n by 2 within bracket 2a plus n minus 1 into d. So, if x is equal to 1 and common difference is 1, so it will become n by 2, 2m is 2 into 1 plus n minus 1, d is also 1. So, this will be equal to n by 2, this is 2 plus n minus 1. So, this will become n by 2 multiplied by n plus 1. So, this is a standard formula that the sum of first n natural number becomes n into n plus 1 by 2 sigma I okay. Now, we will find out the sum of the squares of first n natural numbers. So, sigma, let us say n square, that is the series is 1 square plus 2 square plus 3 square n square. How will you find out? So, from your high school mathematics, you must be remembering this formula a minus b whole cube, it is equal to a q minus 3 a square b plus 3 a b square minus b q. Now, we will use this formula for finding n minus 1 q, where a is equal to n and b is equal to 1. So, it will become a q means n q minus 3 into a square n square, b is 1 plus 3 into n into b square is 1 minus b q 1, 1 q is 1. So, this becomes n q minus 3 n square plus 3 n minus 1. So, this gives, if I take n minus 1 q this side, so n q minus n minus 1 q, and these three terms we will take this side. So, this will become 3n square minus 3n plus 1. So, we will use this formula for finding out this summation. Let us see how we are going to use this formula. So, at the place of n, if I put 1, so 1 q minus 0 q will be equal to 3 into n square, 3 into 1 square. So, 3 into 1 square minus 3 into n minus 3 into 1 plus 1 plus 1. then I put n is equal to 2. So, 2q minus 1q, n minus 1 is equal to 1. This will be equal to 3 into 2 square, because at the place of n I have put 2, minus 3 into 2 plus 1. Again I put n is equal to 3. So, 3q minus 2q, n minus 1 will become 2. So, this will be equal to 3 into 3 square minus 3 into 3 plus 1. So, similarly we write it till n minus till n. Now, we sum it. So, we will find its summation. Now, you can see that if we sum the left hand side, so this is 1q minus 1q. So, this will cancel out. This 2q, this is minus 2q, cancel out. Every term will cancel out till here. So, on LHS it will become, it will be there nq, it will remain nq minus 0q is equal to, on the right hand side we take 3 common everywhere. So, 3 within bracket 1 square plus 2 square plus 3 square. So, this series will come. N square minus, again I take 3 common here in this second term. So, within bracket 1 plus 2 plus 3, this another series will come. And then these 1 will be n times. So, plus n. So, you see friends, we have to find out the sum of first n natural number, square of first n natural number. This is coming here in the bracket s. So, suppose this we take as s. So, here nq 0 will be 0 is equal to 3 s, because this is s minus 3. We know the sum of this, we have already done here in the previous example. Its sum will be n into n plus 1 divided by 2. Okay, plus n. Now, we have to find out this s. So, we will keep 3s here and rest of the things we will take this side. So, this will become nq and this n will become minus n here, minus n, and this will be plus 3n into n plus 1 divided by 2. Now, if I take n common here, this will become n within bracket n square minus 1, which we can write n minus 1 into n plus 1 plus 3n n plus 1 divided by 2. Now, Now, from here 3s will be equal to, you see we can take common in these two terms, n into n plus 1 is common in both the terms. So, I take common n into n plus 1. So, what will be there within brackets? This will be n minus 1 and then plus here 3 by 2. So, this will be equal to n into n plus 1, and if we simplify it, so this will become 2 here and 2n minus 2 plus 3. So, this will become n into n plus 1, n plus 1 and minus 2 plus 3. So, it will become 2n plus 1 divided by 2. So, what will the value of s, because we have to find out s, the summation, this one 1 square plus 2 square plus 3 square till ln square n square. So, this will be equal to n into n plus 1 into 2n plus 1 divided by 6, because this 3 will come this side at the denominator. So, 3 multiplied by 2, it will be 6. So, this is the formula you should remember for sigma. This is sigma n square. Okay. Now, another important series we are going to sum in the similar fashion, method of induction. Say sigma n cube, it means s is equal to 1 cube plus 2 cube plus 3 cube till n cube. Okay. So, as we did before, similarly we will take this from your high school mathematics. You must be remembering a minus b raised to power 4, its formula is a4 minus 3 a cube b plus 6 a square b square minus 3 a b cube plus b4. So, we put a as n and b as 1. So, the formula for this will be equal to n minus 1 will be equal to, put A is equal to n. So, n bar 4 minus 3 n q, B will be 1 plus 6 n square into 1 minus 3 n into B q will be 1 plus 1 to the power 4 will be 1. So, this will become n 4 minus 3 n q plus 6 n square minus 3 n plus 1. Now, I have to find out n 4 minus n minus 1 to the power 4. So, I take this on this side and other terms on this side. So, this will become n 4 minus n minus 1 power 4 will be equal to, the sign of these will be reversed. So, 3 n q minus 6 n square plus 3 n minus 1. Now, as we did earlier, we will do, we put n is equal to 1. So, 1 to the power 4 minus 0 to the power 4 will be equal to 3 into 1 cube minus 6 into 1 square plus 3 into 1 minus 1. By method of induction, we put n is equal to 2. So, 2 to the power 4 minus 1 to the power 4 is equal to 3 into 2 cube minus 6 into 2 square plus 3 into 2 minus 1. And similarly, we can go on doing this till the nth term n 4 minus n minus 1 4 is equal to 3 into n cube minus 6 into n square plus 3 into n minus 1. If we add both sides, so LHS, similarly these will be cancelled out and only the last term and 0 4, it will remain here on LHS. So, n 4 minus 0 4 will be equal to, if I take 3 common here, so within bracket this is the summation we want actually. So, this is coming minus 6 1 square plus 2 square n square. So, we have already done it. So, you know its summation. You know also this summation, and then this is equal to minus n times this one will come. So, this is minus n. So, now if you carry out we will find out the required formula for sum of the cube of first n natural numbers. So, let us do it quickly. So, this is the LHS will be equal to N4 is equal to 3. This is the S 1q plus 2q plus 3q S. So, we write it as S minus 6, this 1 square plus 2 square plus, we have already done this summation, and what is the formula for it? N into n plus 1. So, this is n into n plus 1 into 2n plus 1 divided by 6. Okay. Then again plus 3, 1 plus 2 plus 3 plus till n. So, this also you know, we have already derived it, 3, and this is equal to n into n plus 1 divided by 2, then minus n. So, if I take 3s at one side and remaining we take on the other side, so this equation will become 3s is equal to n4, and all these three terms its sign will be changed. So, n4 plus n, this will be cancelled out, and I hope I have written the formula correctly. Oh, actually, the formula for a minus b whole 4 there is slight mistake I have done. It is, you see the formula for this is equal to A4 minus 4 a cube b. Actually, I wrote here 3. So, let us correct it, it will be 4, and then 6 a square b square minus 4 a b cube plus b4. So, this is the formula. So, there will be slight change here, instead of 3 it will be become 4. So, this term will become 4, and here also it will be 4 instead of 3. Okay. So, this will remain 6. Here instead of 3, it will become 4, and here also at the place of 3 it will be equal to 4. So, here this will be cancelled out, it will become 2. Okay. So, now (4s) will be equal to n4, and this minus n will become plus n here, and this will become plus n into n plus 1 into 2n plus 1. So, 6 has been cancelled out, plus 2n into n plus 1. Okay. So, here if I take n common in first two terms, so this will become n q plus 1. So, if you remember the formula a q plus p q, so it will become a square plus b square minus ab. So, n into n plus 1 okay, because I am taking n common. So, n q plus 1. So, if we expand n q plus 1, so this will become n plus 1 into n square So, let us see the plus 1 square minus 1 plus 1 square will be 1 minus n. It becomes a square plus b square minus ab, aq plus bq. So, this will be the formula plus n into n plus 1 into 2n plus 1 plus 2n into n plus 1. So, friends, you can see that n into n plus 1 is in the first term. In the second term also n into n plus 1 is there, and in the third term n into n plus 1 is there. So, we will take n into n plus 1 common. So, I take n into n plus 1 common here. So, then within brackets it remains n square plus 1 minus n here plus 2n plus 1 and here n into n plus 1 we have taken. So, 2. This will remain. So, this will become n into n plus 1 and within bracket it will be n square. This is 1 plus 1 2 . again this 2, I think I have done a mistake here. So, friends, this term was negative. So, when we put it on the other side, it became positive. Okay? And this term was positive. So, if we take it on the other side, it will become negative. So, here we have committed a mistake. So, it will become negative minus. So, this 2 will be minus. Okay. So, now this 1 plus 1 minus 2, this will be cancelled out. Actually, that is how I found out by mistake, because it should cancel out. So, it will become n square, and 2n minus 1 will be plus n. So, if I take n common from these two terms, so this will become n into n plus 1 again. So, this will become n square into n plus 1 square. So, S will be equal to, the 4 will come this side. So, this will become n into n plus 1 divided by 2 whole square, because it is 4 here. So, we can take it within the square, n into n plus 1 whole square. So, this is the formula. You should remember, because it will be used at many places. So, this is NQ. So, today we derived 3 important summation formula, which will be used at many places. Now, let us see some simplified concept of convergence of series. Convergence of series is a very big chapter, but in your syllabus very preliminary concept is given. So, I will discuss only that. Suppose a series is there, now we should observe that how the series is behaving. It may be that the previous term, so say x I minus 1 is smaller than x I. It means that the terms are successively increasing for all I 1 to n. So, this is monotonically increasing. This series is monotonically increasing. If on the other hand, if xi minus 1 is greater than xi, then this is monotonically decreasing. There may be series which neither increases nor increases neither of the case 1 or neither of the or case 2. So, we cannot say anything about such series, but about this monotonically decreasing series, if it is converging to a some limit L, say when xn is equal to L when n becomes large. So, then we call L as a limit for this series. So, we write it as n tends to infinity, xn is equal to L, and related to this the concept of convergence and error also comes. So, friends, suppose there is a positive integer sigma, quite small, epsilon greater than 0, such that xn minus L is less than equal to epsilon for n greater than sum n greater than equal to 1. Okay. So, it means that this series is convergent. So, series is said to be convergent if and only if there exists you understand the concept, a small quantity epsilon which is greater than how much whatever a small number you can select epsilon, but the series will be converged only if the xn, the absolute value of xn minus L will be less than equal to epsilon for some value of n greater than Ni. So, it means you just understand the concept. This is the last concept I am giving you, that it is very difficult that if I take epsilon very small. So, this is the error term. The series is converging to L, xn minus L. So, the error term, this is epsilon, error term, can we limit it within this limit? Yes, we can limit it, but if I take epsilon smaller and smaller, then a point will come when this limit will be crossed, but then the condition is that the n will be greater, because this is successively monotonically decreasing series. So, as it goes on, the value of xn, absolute value of xn minus L will become smaller, and this will come within sigma. So, this is the concept of convergence of this series. So, friends, thank you very much for listening. Please ponder over this and you will understand this concept. Thank you.